In this lesson, you will learn to state and apply the properties of parallel lines. Now, here we have a picture of two parallel lines, which are the blue lines, and then a red transversal cutting through. And there are several properties that we have dealing with this kind of picture, when you have two parallel lines and a transversal. And the first property is that the corresponding angles are congruent. Now remember, corresponding angles are the angles that are in corresponding position. So for example, we see up here, we have a group of angles, and then down here we have another group of angles. So the corresponding angles would be such as angle 1 and angle 5, because those are both in the top left corner. Angle 2 and angle 6 are corresponding, angle 3 and angle 7 are corresponding, and then angle 4 and angle 8 are corresponding. So those angles that are corresponding are going to be congruent. So angle 1 and angle 5 are congruent, angle 2 and 6, 3 and 7, and 4 and 8 would be congruent. By the way, take note of the congruent sign. We've discussed this before, but just a reminder that the congruent sign is an equal sign with a little squiggly line above it. So that is your first property. Second property is that alternate interior angles are congruent. So in the last lesson, we learned that alternate interior angles are angles that are on alternate sides of the transversal, they're non-adjacent, and they're interior as well. So for example, looking at angle 3 is on the left side of the transversal of this red line, and it's on the inside of the two blue lines. Angle 4, 5, and 6 are also interior. They're on the inside of the two blue lines. So which one is the alternate interior? Well, the alternate means on the other side of the transversal, so it's got to be on the right side, but it cannot be adjacent. So angle 4 would not be alternate interior, but angle 6 would be. They're on opposite sides of the transversal, and they are also interior. So angle 3 and 6 would be congruent based off the second property. And then angle 4 and angle 5 are also alternate interior. They're on opposite sides of the transversal, they're interior, and they're not adjacent. So angle 4 and angle 5 would be congruent as well. The third property says that same side interior angles are supplementary. So same side interior would be something like 3 and 5, and then 4 and 6. Where 3 and 5, they're on the same side of this red transversal line. They're both on the left side, and they're also both interior. They're inside of the two blue lines. Then 4 and 6 would be same side interior as well. So this property says that if you add angle 3 and 5 together, it's going to equal 180 degrees. Because supplementary, by definition, means two angles that add up to be 180. And then angle 4 and angle 6 would also add up to be 180 degrees as well. The fourth property says that if the transversal is perpendicular to one of the parallel lines, then it is perpendicular to the other parallel line also. So what this would mean is that if this red transversal is perpendicular to this top blue line, meaning it creates a 90-degree angle up here, then if that is true, and the two blue lines are parallel, then we also know that angle 5, or these lines down here, are also perpendicular. Which makes sense, right? Because if this angle 1 is 90 degrees, then we can conclude, based off the other properties, that these other angles down here would also be 90. Right? Because vertical angles are congruent. We learned that before. So angle 4 would also be 90 degrees. We learned that the alternate interior angles are congruent. So if angle 4 is 90, then angle 5 would also be 90, because those are both alternate interior angles. So we can conclude that if angle 1 is 90 degrees, or if just any of the angles up here are 90, then all of the angles will be 90 degrees as well. So if angle 1 is 90, the measure of angle 5 is 90, and therefore we have two sets of perpendicular lines. So to recap everything we just said, if you have two parallel lines with a transversal, then corresponding angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary, And if the transversal is perpendicular to one of the parallel lines, then it is also perpendicular to the other parallel line as well. Now, how can we use this to find different answers to questions we may have? Well, here's an example where measure of angle 2 is 105 degrees. So this angle right here, angle 2, is 105 degrees. And our objective is to find all the other angle measures. So we can start with angle 1. We know that angle 1 and 2 put together make the entire blue line. And a line has 180 degrees. So if I take angle 1 plus angle 2, I know my answer is going to be 180. So what plus the 105 would give you 180? Well, if I take 180 minus 105, that's going to give me my answer of 75 degrees. So angle 1 right here is 75 degrees. And then we can find angle 3 pretty quick using the same logic. Angle 1 plus 3 add up to give me this red line. So 75 plus something gives me 180 degrees, the entire line. 75 plus 105 would give you that 180. So angle 3 is 105 degrees. We could have also gotten that by using the fact that angle 2 and angle 3 are vertical angles, so therefore they would be congruent. Either way, we get 105 degrees. Then angle 4, we know is a vertical angle to angle 1. So angle 1 and 4 are vertical angles, so those are going to be congruent. So if angle 1 is 75 degrees, angle 4 would also be 75 degrees. And then angle 5 we can find very quick using our property that says that alternate interior angles are congruent. If angle 4 is 75 degrees, then angle 5, the alternate interior angle, would also be 75 degrees. And then angle 6 and angle 5 add up to give me the entire blue line down here, which a line is 180 degrees. So 75 plus 105 would give you 180. So measure of angle 6 would be 105 degrees. And then angle 7 is a vertical angle to angle 6, so those are going to be congruent. So angle 7 would also be 105 degrees. And then angle 8 is vertical with angle 5, and vertical angles are congruent. So angle 5 is 75 degrees. Angle 8 would also be 75 degrees. Now here's another picture. And notice this blue triangle on the top line and the bottom line. That little triangle implies or means that we have parallel lines. So in a picture, if it's not told to you that we have parallel lines, but we see these triangles on here, these triangles mean that those two lines are parallel. And now the question is, what is x and what is y? Well, it might be helpful to extend this line a little bit. So extend the top line and then extend this bottom line. And if you want, you can extend this line as well. So look over here on the left side at the 105 degrees and the x degrees. What we can do is we can use the fact that we have different types of angles that are created when we have a transversal cutting through two lines. So if we look here at this line that cuts through the two parallel lines, this is the transversal, and then the two top and bottom lines would be the parallel lines. So the question is, how do this 105 degree angle and the other angle down here relate? What kind of angles are they? Well, they are on the same side of the transversal and they're both interior. So those are same side interior angles. And based off one of our properties that we learned, we know that same side interior angles are supplementary. Meaning if we take 105 plus x, we're going to get 180 degrees. So we can solve this for x by subtracting 105 from both sides, and we get x equals 75 degrees. So the answer for angle x would be 75 degrees. Now we're going to do the same thing, but now over here with angle y. So if we want, we can extend this line a little bit, extend this line, and then maybe extend this down, extend this across, and it might be helpful to visualize what's happening. And then we're going to ignore the 105 and the x degree over here. So the question is, how does y relate to 120? Because they're both shared on the same transversal. Well, once again, they're both interior. They're both inside of the two parallel lines. Also, they are both on the left side of this transversal, this line cutting through. So 120 and y would also be same side interior angles, where we just stated that same side interior angles are going to be supplementary. Meaning, if I take 120 and add that with y, that's going to equal 180 degrees. So the question is, 120 plus what gives you 180? Well, that's going to be 60. So y would equal 60 degrees. Now let's take a look at one last example. And here we have many different things going on. We have our two parallel lines with the triangle to represent that they're parallel. And then we have one and two other lines cutting through. And so this one is kind of convoluted and may be difficult to visualize what is going on. But our objective is still the same. We're trying to find the value for x and y. Now what you need to learn to do is ignore the irrelevant parts and look only at the parts that will help you to solve the answer. So if you take a look at the two parallel lines, we need those for sure because we want to use one of those properties to set two angles equal to each other. So look at that line and then this line right here. Now look at those two lines, and then we can take a look at maybe this transversal. So just looking at what I have highlighted in red, everything else is going to be irrelevant. Well, with what I've just drawn here and the angles that are given to me, what angles are given to me that actually are created by the lines that I've highlighted? Well, y is not created by these lines. 30 degrees is also not created by those lines. But we see 80 degrees is created by the one parallel line in the transversal, and then x degrees over here is created by those two lines as well. Now the question is, how do those two angles relate? Well, notice that we have the one group of angles right here. We have angle 1, 2, 3, 4, and up here we have 4 angles as well. And notice that 80 degrees is on the top left corner of that group of angles, and angle x is also in the top left corner of these group of angles. So they're both in the top left corner, so those would be considered corresponding angles. So the 80 degree angle and the x degree angle are corresponding. And we learned that if we have parallel lines and a transversal cutting through, that corresponding angles are going to be congruent, meaning that angle x would also have to be 80 degrees. So we've just solved for x. Now we need to figure out what is y equal to. Well, what I can do is, since I know this is 80 degrees, and then I also know this angle is 30 degrees. Well, the vertical angle of this 30 degree angle would be up here. So we know that this is also 30 degrees. So we have 80 degrees plus 30 degrees. So this gives me 110 degrees so far. But then notice if I add in just this one other angle, angle y, I'm going to get this entire line. So what I can do is use the fact that there are 180 degrees in a line, and then subtract out the 110 degrees already used to conclude that angle y would have to be 70. So that 80 plus 30 plus 70 would give me 180 degrees total. So y would be equal to 70 degrees. And that concludes our lesson for today. We will see you next time.